Hello, everyone. Good morning, good afternoon, good evening, depending on the time of day in which you are watching this video. So what I wanted to do for this particular video is to kind of go through these ideas of fluxes and reservoirs and outflows, or inflows, reservoirs, outflows, but in some ways that maybe we didn't think about. In class when we met last, we talked about, the simple bathtub method and, how we can go from an open system to a closed system. And I kind of gave some other examples here and there, but for this particular video, I just kind of want to rehash that a little bit, especially if you were not in class that day for whatever reason. So just to kind of really cement these ideas. And then in a subsequent video, I will go through the software that we're going to use in order to visualize this idea. So with that all said, here we go. So this is, of course, because I'm out of town at the moment. So I'm saying this is kind of week 2. So we're not doing like 2 separate days of stuff, because the discussion board for this week actually will be kind of a useful use of your time to do it when we would normally have class. So going back to this idea of a simple example of a dynamic system, that of a bathtub, right? So we have our inflow, our reservoir, and our outflow. And as long as there's a balance between the water coming in and the water leaving, then we would say that it's working just fine. This is an open system, so we're not keeping track of where the water is coming from or where the water is draining to. So we don't have a source and a sink, if you will. Those two terms are going to be pretty useful when we talk about Earth climate system stuff, sources and sinks, things like that. And the flux of this, so we can make the faucet kind of just dribble, or we can turn it on full blast, which would then adjust that flow rate or that flux. And even if the water in the bathtub remains constant, the individual water molecules are still moving throughout the system. So the way that you can think about it, and this will be a little hint here, if a water molecule drops into the top of this water level, eventually maybe it'll get almost kind of through forces, get sucked down into the drain before other water molecules. The water level will still stay the same, right? Because your flux in is the same as your flux out. So that's kind of a little more complicated way to think about what's going on within the system itself, rather than just what we visually see of incoming and outgoing. If that makes sense. And then this is, of course, a dynamic system, because the material flowing in and the rates of flow and the amount of water in the tub may change over time. It's a very, very simple example, of course, but there are analogies all around us that can help explain these ideas as well. One example, I know a lot of us are outdoorsy folks, so this can be one that maybe you've seen before, is that of a pond, right? So your inflow for that pond could be some runoff from off of mountainsides here, or precipitation can help fill that pond. And then maybe there's a stream outlet, which can then allow water to flow out of the pond or lake. So that's why we have an influx, a reservoir, and an inflow, not influx. Inflow, reservoir, outflow. Very simple, one and easy system. Another one is that of glaciers, right? So we have inflow, which could be our snowfall and our ice. And the reservoir itself is a glacier. And then the outflow would be the melting and icebergs calving off. So if all things are kind of going in balance, if there's not some sort of feedback, or if there's not any sort of positive feedback going on and all things are in equilibrium, then the amount of snowfall will equal the same amount of melting and icebergs. So that the glacier itself will not necessarily net grow or decrease, if that makes sense. Of course, we can see this with pretend that we're not going through climate change currently. We're not seeing a decline of sea ice. seasonally, we can see these variations, right? In the winter season, we see the glaciers grow. In the summer season, we see the glaciers shrink, but the overall net amount of ice would stay the same if things weren't going the way they're going right now. Another example, speaking of climate and climate change, would be, of course, the ideal version of CO2. So we have I'm sorry, that's not supposed to say outflow, or inflow of CO2. So our respiration and decomposition, which puts atmosphere into the atmosphere, CO2 into the atmosphere at about 6 gigatons per year. Oh, and remember when we're talking about inflows and outflows, they are a rate, right? So an amount per time. And the amount, of course, can change whatever variable we're talking about. So in terms of CO2, we have gigatons of carbon per year. And the atmospheric CO2 would stay at about 760 gigatons. Is a reservoir. That's just the regular set amount. There's really no in or out there. And then the outflow, of course, is photosynthesis. So our trees and our plants do their photosynthesizing thing and take in about 60 gigatons a year. So the inflow is equal to the outflow, which means everything is all up in balance overall. This is also a seasonal effect, of course, as well. If we look at the Keeling curve, which is what we use to measure atmospheric CO2 in the northern hemisphere, we can see these little oscillations, and that's mostly due to seasonal variation, right? In the summertime, spring and summertime, all the trees and the greens and everything are all kind of, woo, I'm doing my thing. I'm up and about, taking in CO2 and taking in sun energy. I'm here for it. But then in the wintertime, the trees will lose their leaves, and then the trees go dormant, and they're no longer taking in CO2. You could even consider, like, within photosynthesis, even there's a smaller feedback loop, or not a feedback loop, but a smaller sort of systems loop going on within photosynthesis as well. It's really quite fascinating. And then if we think in a society, we think of a parking lot, right? We have an inflow, which would be the entrance to the parking lot, and the outflow is the exit. Sometimes it's on the same side. Maybe there's multiple inflows and outflows, and the reservoir itself would be a parking lot. Excuse me. And, parking lots differ from parking lot to parking lot. I don't know why, but it's always the Trader Joe's parking lots that are the most horrendous ones that are just built in such an odd way. You're just like, what is happening? It's chaos. But it's not always that the amount of cars flowing in is the same as going out. But one could argue if it's a full parking lot, at least someone's leaving at some point to hopefully allow for more people to park. Last example that you could maybe see in your everyday life would, of course, be in society with banks. So a bank account, not just like the bank itself, but your own personal bank account. You have your source of inflow, which would be your income, which gets stored in your bank. And then the outflow is the spending. So is the amount of income equating the amount of spending, then that would mean that you don't have any net savings going on, or you're not in the negative, you're not incurring debt. So that things would be, for all intents and purposes, in balance. Which, of course, financially you don't want to be in balance. You want to have you want to have more coming in than you have coming out, but sometimes that doesn't always happen, right? So what we're going to be